In the heart of Texas, more than 2 billion cubic meters of fresh water are being held behind an earthen wall nearly 4 kilometers long. This is Livingston Dam, one of the largest earthen dams in Texas and the lifeline of more than 3 million people for nearly 60 years. However, satellites in space have recently detected something unusual. Radar data shows that this megastructure is quietly moving by a few millimeters every year. So, what is really happening beneath one of the most important infrastructure projects in Texas? Let's join Mandarin Tech to explore this story in today's video. Livingston Dam is located on the Trinity River, about 120 kilometers northeast of Houston. Construction began in 1966 and was completed just 3 years later, creating one of the largest earthen dams in Texas with a length of more than 4 kilometers. Lake Livingston stretches out beyond the dam, covering about 83,000 acres and holding up to 2.2 billion cubic meters of fresh water. It has become an important water source for Houston, as well as many residential communities, industrial areas, and agricultural operations across the region. Despite its impressive scale, the structure has now been in operation for nearly 60 years. And it is precisely this age that has led engineers to pay closer attention to even the smallest changes occurring within the dam. At its core, it is a massive reservoir where the water flowing in must ultimately be released downstream. But after nearly 60 years of operation, this seemingly unchanging structure has begun to show unusual signs that are difficult to detect with the naked eye. In the past, dam safety monitoring relied mainly on sensors installed on the structure, field surveys, and routine inspections. However, advances in satellite radar technology have introduced an entirely new approach, monitoring the movement of an entire structure from space. The European Space Agency currently operates the Sentinel-1 satellite pair, using a technology known as INSAR, Interferometric Synthetic Aperture Radar. These satellites can detect ground deformation with millimeter-level precision by comparing radar signals collected during multiple passes over the same area. The results revealed that the northern section of the dam is subsiding by about 8 millimeters per year, while the southern section is rising at a nearly similar rate. In other words, two parts of the same structure are moving in opposite directions. In geotechnical engineering, this phenomenon is known as differential settlement. For an earthen dam stretching more than 4 kilometers in length, it is a type of deformation that requires particularly close monitoring. When the foundation moves unevenly, stresses can build up within the dam body, increasing the risk of internal seepage paths that cannot be detected by the naked eye. Adding to the concern, Livingston Dam is currently classified as being in unsatisfactory condition under the United States National Dam Assessment System. However, this does not mean the dam is in immediate danger of failure. Experts emphasize that satellite data serves primarily as an early warning tool, helping identify areas that require closer inspection. But when two independent research teams detect deformation zones on the same structure, an important question begins to emerge. Is this simply the normal aging process of a dam approaching 60 years of service? Or is it a sign that larger challenges are developing beneath Livingston Dam? To understand why deformations of just a few millimeters per year have attracted the attention of engineers, we need to look at the role Livingston Dam plays. The issue is not the 8 millimeters themselves. The issue is what lies behind the dam. Held back by the earthen wall stretching more than 4 kilometers is about 2 billion cubic meters of fresh water, one of the most important water reserves in Texas. For nearly 60 years, Lake Livingston has been an essential part of the water supply system serving Houston, as well as many residential communities, industrial areas, and agricultural regions throughout the Trinity River Basin. Every day, millions of people turn on their taps, factories continue operating, and cities continue growing without giving much thought to where that water comes from. But for Texas, Livingston Dam is far more than just a dam. It is part of the system that sustains more than 3 million people. That is why engineers cannot afford to ignore any unusual sign, even one measured in only a few millimeters per year, When a structure responsible for supplying water to millions of people begins to show signs of deformation, the real concern is not the size of the change itself, but the consequences if that change continues for years to come. Throughout nearly 60 years of operation, Livingston Dam has had to withstand not only the passage of time, but also repeated tests from nature. In September 2005, Hurricane Rita struck Texas with extremely powerful winds, generating large waves that continuously swept across Lake Livingston. Although the dam did not face a historic flood event, it was subjected to a very different type of force, the energy of wind and waves. For hours, waves about 1.2 meters high repeatedly crashed against the upstream slope of the dam. For a structure stretching more than 4 kilometers in length, this was equivalent to thousands of impacts occurring simultaneously across the entire face of the dam. The damage soon became apparent. More than 3 kilometers of the outer protective rock layer was washed away or severely damaged. Engineers refer to this material as riprap, a layer of rock that serves as an armor shield, absorbing wave energy before it can directly impact the earthen dam behind it. Once that protective layer was compromised, the earthen core of the structure faced a much greater risk of erosion. To repair the damage, the operating authority had to mobilize more than 72,000 tons of rock and approximately 3,000 truckloads to restore the dam's slope. This was not simply a repair project. It was a race to rebuild the first line of defense protecting the structure. If Rita tested the outer defenses of Livingston Dam, Hurricane Harvey in 2017 put the entire operation of the structure to the test. In late August 2017, Harvey made landfall in Texas and quickly became one of the costliest natural disasters in American history. Massive rainfall across the Trinity River basin sent huge volumes of water flowing into Lake Livingston from throughout the region. Water levels in the reservoir began rising rapidly. For the first time in many years, all eyes were on Livingston Dam. Communities along the lower Trinity River closely monitored operational updates, knowing that every gate release decision could directly affect tens of thousands of people downstream. To control the reservoir level, the floodgates had to discharge more than 110,000 cubic feet of water per second. An enormous volume of water was routed through the spillway system to prevent the lake from rising further. Unlike Rita, the challenge this time was no longer about protecting the dam's outer defenses. The task was to protect the structure while also minimizing flood risks for downstream communities. For days, Livingston Dam became one of the most closely watched pieces of infrastructure in Texas. In May 2024, Livingston Dam recorded the largest release in its operating history, with a discharge rate of approximately 124,000 cubic feet per second. The force of the flow was so powerful that part of the left training wall near the spillway was damaged, prompting federal agencies and the dam operator to launch a separate engineering investigation. Interestingly, despite repeatedly becoming a focal point during some of Texas's largest storm events, Livingston Dam was never built primarily for flood control. The original purpose of the project was straightforward: to store water and supply it to Houston and surrounding areas. That creates a major difference in how the dam is operated. Many flood control reservoirs are designed with dedicated storage capacity reserved for major inflows. During heavy storms, they can retain a significant volume of water to reduce downstream flooding. Livingston Dam operates differently. It functions largely as a massive water storage reservoir. Whatever volume of water flows into the lake must eventually be released back into the Trinity River. The dam was not designed to hold floodwaters for extended periods. This helped explain why, whenever extreme rainfall occurs, operators must constantly strike a delicate balance. Release too little water, and reservoir levels continue to rise, increasing pressure on the structure. Release too much and downstream communities may face a greater flood risk. It is a challenge with no perfect solution. And as extreme weather events become more frequent, the pressure on Livingston Dam's operating system continues to grow. That reality became especially clear in 2024, when the dam recorded the largest release in its operating history. Discharge through the spillway reached approximately 124,260 cubic feet per second, equivalent to more than 3,500 cubic meters of water every second. To To put that into perspective, every second, enough water was being released downstream to fill more than one Olympic-sized swimming pool, and that process continued for hours. Large dams around the world are typically built with two primary goals in mind: water management and power generation. Livingston Dam followed a different path. Although the dam was completed in 1969, it operated for more than half a century without a large-scale hydropower facility. For over 50 years, billions of cubic meters of water flowed through the system without generating a single kilowatt of electricity. The turning point came in 2021 with the commissioning of the R.C. Thomas Hydroelectric Project. Rather than building a new dam or expanding the reservoir, engineers integrated a power generation system into the existing infrastructure, taking advantage of water that was already being released through the dam every day. As water passes through the turbines, the energy of the flowing water is converted into electricity before returning to the Trinity River. As a result, Livingston Dam gained an entirely new function without significantly changing the way the reservoir operates. Today, the facility can supply electricity to approximately 12,000 households while helping reduce tens of thousands of tons of carbon emissions each year. But perhaps the project's greatest significance lies beyond its power output. It demonstrates how infrastructure built in the 1960s can still adapt to the demands of the 21st century. While many aging infrastructure systems across the United States are gradually deteriorating, Livingston Dam has been given a new role, extending its service life and increasing the value of the structure itself. After more than half a century, Lake Livingston has become much more than a reservoir serving human needs. Covering approximately 83,000 acres and featuring hundreds of kilometers of shoreline, it has gradually developed into one of Texas' most popular destinations for fishing and outdoor recreation. And within this man-made lake, some remarkable stories continue to emerge. One of its most famous residents is the alligator gar, a species often referred to as a living fossil of North America. These fish first appeared tens of millions of years ago and have changed very little since then. With their long snouts lined with sharp teeth, they look like a cross between a fish and an alligator. In 2025, an angler at Lake Livingston landed an alligator gar weighing about 153 pounds, or nearly 70 kilograms, and measuring more than 2.2 meters in length. The battle lasted nearly 4 hours before the fish was finally brought ashore. Lake Livingston is not only known for its freshwater giants. In 2025, the reservoir also recorded a new world fishing record when a white bass caught in the lakes was officially recognized by the International Game Fish Association. Behind these achievements is a large-scale fisheries management program. Each year, nearly 1 million young fish are released into the reservoir to help maintain fish populations and support a healthy ecosystem. Perhaps this is one of the most fascinating aspects of Livingston Dam. People built the reservoir to store water. But over time, it evolved into a vast ecosystem, a recreational destination, and an integral part of life across the region. It is a journey that few could have imagined in 1969, when the first waters began collecting behind the dam. For nearly 60 years, Livingston Dam has remained a vital part of Texas's water supply system. It has endured powerful storms, historic rainfall events, and decades of continuous operation while continuing to provide water for millions of people every day. Today, there is no evidence that the dam faces an immediate safety threat. Yet the satellite observations discussed in this video have revealed something important. Even massive structures that appear unchanged to the naked eye are constantly evolving. Over time, foundations settle, materials age, and small movements can occur within the structure itself. What makes this story remarkable is that engineers no longer have to rely solely on what they can see on the ground. Using modern satellite radar technology, they can now detect movements measured in just a few millimeters, monitor changes across an entire structure, and identify areas that may require closer inspection long before visible problems appear. And perhaps that is the most fascinating part of the Livingston Dam story. It is more than just a nearly 60-year-old dam holding back billions of cubic meters of water. It is also an example of how technology is transforming the way critical infrastructure is monitored, maintained, and protected for future generations. As dams, bridges, and other major infrastructure systems continue to age around the world, tools like satellite monitoring may play an increasingly important role in helping engineers keep them safe and reliable for decades to come. If you enjoyed this video, be sure to leave your thoughts in the comments below. And don't forget to subscribe to Mandarin Tech so you won't miss our next engineering story.